you ready to go? Let's do angles of elevation and depression. I know, it's a mood. All right, so angles of elevation is if I'm looking straight, it's up at something else. So here's my little dude. Here's my line of sight. Here's the angle of elevation is line of sight up. And then angle of depression is the angle downward from line of sight. So same thing, I'm standing. Here's my line of sight. And then here's my angle of depression. It's when I'm looking down. This is really common if I'm looking like up at somebody on top of a bridge. And this is more common if I'm on a high level of something and I'm looking down at whatever's below me. Because I don't usually look down into the ground, but it's still possible. It's just that angle either up or down from your line of sight. I didn't scare you, sorry. You're skiing down a mountain with an altitude of 1,200 feet. The angle of depression is 21 degrees. Find the distance you ski down the mountain to the nearest foot. Surprise, we're doing word problems now. A lot of times these word problems will come with a picture. This actually did come with a picture in the textbook. It's example like 4 from section 9.6, I think. But I just wanted to show you how we draw pictures when we're only given words, even though sometimes you will be given pictures, you won't always. The two homework, well, I'm giving you 3 homework problems. We're gonna do the first type just in a second, but the other 2 are word problems. And I just want to, what's it called when I show you something? Model. I want to model doing this with you. So I have a mountain. I don't care what mountain it is. This could be Stevens Pass. This could be Glacier Peak. This could be, I don't care. We're going to assume it's mostly flat because we are talking about a right triangle, even if it doesn't say that. So here's my little skis. I would wear goggles and stuff normally, but you know. We're not on a precipice like this. We could have been going for a while longer after this. But the key is that right now, I am 1,200 feet up on the mountain, right? This is the base. Here's the lodge. It's got a little like smoke chimney going on. That doesn't look like anything. Lodge. So I'm skiing down the mountain. I'm not going to ski right into the lodge. My perspective's off because this looks about smaller than me, but you know, it does when I'm skiing too. The angle of depression is 21 degrees. So what that means is as I'm looking down the mountain, my angle of depression is 21 degrees. Okay. I'm going to assume that the height of my eyes is negligible to this because I'm going to be rounding anyways. But I would normally, if it tells me about the dude's height, I would probably include that. So 21 degrees is going down. And then I'm trying to figure out how far I'm going to be skiing down the mountain. I want to know this. I want to know the hypotenuse. Okay. This 21 degrees has nothing to do with this triangle right now, right? Well, here's the thing though. My line of sight is always parallel to the ground, like the base level ground, not like this ground, obviously. But my line of sight, if I'm just looking straight, is perpendicular to the ground. So what that means is that my line of sight is actually equal to this angle down here. So angle of depression and I guess angle of elevation, if you're like on the ground looking up, will be equal. So that means that this is also 21 degrees. Should I have made that a different color? Probably. It's fine. People who are looking at this won't possibly get confused. We'll just say it's down there. Okay, so to solve this triangle, I'm going to, or to find the value of x at least, I'm going to just pretend like this is a normal right triangle. I don't really care about the fact that I'm partially submerged in snow, way bigger than the lodge. I just want to know that if this is my angle, theta, this is my opposite side, and this is hypotenuse. And then this is the adjacent side. We don't really need it. But anyways, I'm going to go, okay, well, out of Sohcahtoa, the angle here, I have the opposite and I want the hypotenuse. So O and H is sine, my favorite one. So we're going to do sine of, why did I switch colors? I don't know. 21 degrees equals 1,200 over x. I go to my calculator, which was hidden behind the board games. I go to my calculator and I say, hey, calculator, what is sine of 21 degrees? And it tells me the wrong number because I'm in radians, so I need to switch that to degrees. You don't need to do it every time. I just happen to be tutoring a kid in calculus, and he needs it in degrees. So in my calculator, it says y, by golly, that's 0.35. 8. Okay, so then I can do the good old switcheroo. I'm not going to show you again, but if you want to go back, you can check multiply by x, divide by 0.358. It'll end up switching. I don't want to. I don't want to do it every time. Okay, now here's my trick. Whenever I do this, I do 1200 divided by, and then I select the answer from earlier, so it uses the whole thing. 3348, oops, 0.51. But my question specifically says to the nearest foot, right? So I actually just want the 3349 because I'm rounding. But it asked me in words, I need to respond in words. That's how math works, right? So you travel 3349 feet down the mountain. Okay. Now I just want to just really quick clarify one more time that if you had a different, if you said the degree was here, you'd get a very different answer because then you'd be using cosine and it would be wrong. So if you're getting this wrong, it might be because of the way you drew your picture. So just make sure you put the things where they belong. That's it. Okay, and then before I go, one more thing. I don't like this nomenclature. I don't like the way that they said this. But they use this word to solve. And so in order to solve a triangle, we need to find every angle and every side. So before, in the last couple episodes of geometry, I've asked you to find one thing, like find the hypotenuse, find the adjacent side, find the angle measure. To solve a triangle completely, we're going to find everything that's missing. So let me do one example with you, and then you'll get it. You'll be fine. Ta-da! Okay, and the one thing I might have told you but maybe didn't tell you is that the sides opposite from the angles has the same letter, it's just lowercase. So if this is angle A, this is side A, if this is angle B, this is side B, and if this is angle C, this is side C. They're across from each other. So let's get started. So I need to find, here's my 3 things I need to find. I need to find the measure of angle B. I need to find side length B, and I need to find side length A. Those are the 3 things I need to find. One of those I'm already done, basically. Like not actually, but almost. Because this is 41, that's 90. I can easily do the sum equals 180. So I can do 41 plus 90, and then 180 minus that. Done. 49 degrees. So that's, I just use the triangle angle sum. Hold up. Okay, so it's 49 degrees. For sides B or A, I can choose either one I prefer. I don't care. And I would just use Sohcahtoa. Actually, let me write that on here too. So here's what I'm going to use, Sohcahtoa. Now I'm going to do B because I accidentally wrote it first, but I could really do these in any order. It's just the next thing I do is going to be using Sohcahtoa. So in order to use Sohcahtoa, I'm going to put my little dude up here. Here's my theta. Here's the opposite side. We've done this before. Here's the hypotenuse, always. Here's the adjacent side. Psh, easy. Okay. So if I want to do Sohcahtoa, to find B, I would use, for adjacent and hypotenuse, I would use cosine. But I'm going to show you my work. Sorry. So I'm going to use Sohcahtoa. Adjacent and hypotenuse is ka. Oops. I usually just do that. Ugh, ew, gross. Ew. So I'm using cosine. So I'm going to do cosine. Again, I don't know why I just write that part in purple now. Of 41 degrees equals B over 18.4. So I'm going to say, hey, calculator, what is cosine of 41 in degrees? And it's going to say, oh my gosh, that's 0.755, obviously. And then I'm going to multiply both sides by 18.4. Gone. So times that by 18.4, and I get B equals 13.887. Okay, I'm just gonna say this one more time. I prefer to leave it in 3 decimal places. At the final answer, they kind of want you just to leave it as like 13.9. That's what the book says. So I'm just gonna do that. Okay, now here's the deal. I could do Sohcahtoa again, but I currently have 2 side lengths. I can just use Pythagorean Theorem. That's gonna be way easier. So first we do triangle angle sum, then Sohcahtoa, then Pythagorean Theorem. Or these 2 can be in any order, I guess. Okay, so for Pythagorean Theorem, I say a squared plus b squared equals c squared. I already know, I don't know a, but I know b is 13.9. And I know c, oops, geez, I'm making mistakes all over the place. That's the beauty of whiteout, friends. Okay, so I can just solve this. We've done this before. If you don't remember, go back to the first 5.5a, I mean, and that should help you remember. I'm just asking my calculator right now what these numbers are by squaring them. In a phone, you can do the same thing. Subtract 193. I wish I had more space for this. I'm so sorry. Oh, I'm gonna pre-warn you. Next lesson, I'm gonna be doing more notes than just 1 page because I want to show you all examples of it. There's 4 different ways these things could represent themselves, so just come prepared. Come on, we got this. Okay, I'm gonna square root that. Square root is the division sign with a little like extra line on it. And I get 12.1. Well, I get 12.056. But up here I rate 12.1. So that's my final answer. I solved the triangle. I found all of the parts of it. All right. See you soon. Goodbye.